So really broadly, if you don't know what Loyal is, we're working on longevity drugs, right? And so what is a longevity drug from the perspective of me slash the company? Um, Look, I'm not gonna like beat you guys over the head with like the same old classical aging BS of like, oh, like $1 trillion market cap, blah, blah, blah. But really the important thing to understand is that as we age, our health, or should I say maybe quality of life, goes down over time. And we kind of classically think about disease in the case of age-related diseases as occurring here, right? You get diagnosed with, God forbid, cancer, Alzheimer's, Parkinson's, dementia, whatever it is, in this later portion of your life. But with a lot of these diseases, while they might be diagnosed formally at this stage, you're often actually developing the predicate of the disease potentially decades ahead of time. There's been some really interesting data showing this in Parkinson's, showing some of the neuronal changes actually in the esophagus, which is terrifying, and the potential link of the enteric nervous system to the CNS. I think we can all just also feel it independently, right? Like my memory, my ability to, memorize things quickly was much stronger when I was 20 than now when I'm 30. But we don't really think about this decline as a disease. We think of everything as kind of a binary, one, healthy, 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 and then you get diagnosed, and then it's a 0 and you're unhealthy. And this is problematic for a number of things, but when it comes to treating age-related diseases, it's problematic because the disease often has a multi-decade head start. There's a lot of reasons why drug development for these age-related diseases has been fraught with challenges. It is not just down to this. But this is a big part of it, right? In the case of Parkinson's, where you lose a specific type of neuron, dopaminergic neurons in your brain, the problem of like, how do you catch up to the loss that's been happening in this patient, again, for potentially decades, is very, very difficult when you're trying to intervene here. Instead of intervening here, where maybe just the initial, protein changes are starting to occur in the brain. And so, again, there's a lot of reasons why it's hard to develop drugs for age-related diseases, but a big part of it, at least to the thesis of Loyal, and I think it's not particularly like controversial statement, is that it's just the disease has decades to do damage before you start classically treating it. So what is an aging drug? From my perspective, it's just basically a drug that's a preventative medicine for age-related diseases, right? Is there drugs that we can do that are still gonna be clear, like we're still gonna have age-related decline, but is there something that we can do that treats, that slows that slope of decline, that reduces your risk of mortality and morbidity, to extend quality of life, which is actually the most important, and also lifespan too. What are some things that we're not doing at Loyal / I'm not doing personally? I'm not interested in immortality. I'm not interested in escape velocity. I'm sure people will do that shit at some point. I'm sure it'll be interesting. But I honestly think there's a massive amount of like low-hanging fruit, relatively speaking, just in this quality of life, kind of dampening the curve area of the age-related decline that we have. And if we could do a little bit of impact here, positive impact here, I think we could have really massive benefit on, wide swaths of society. One really good example, and I wish I had the curve up here, is statins. Statins are a medicine about, I believe, a third of older Americans take to reduce their risk of one category of age-related disease, cholesterol-mediated cardiac disease. Statins have saved millions upon millions of life years just by reducing the risk and delaying the onset of these diseases. And that's just for one very small subset. It's also a very cheap drug, generally considered a very safe drug. And I think that's a really good model for what I want to do at Loyal and what I think a lot of the field wants to do in longevity, which is there preventative medicines that are treating potentially or preventing or reducing the risk of multiple age-related diseases at the same time. Another good comp that's actually become much more recent is the whole weight loss drug, GLP, mania. We're seeing these drugs having impact on weight loss, but also 10 other different indications at the same time. They're like, wow, it's magic. It's actually not. Metabolic fitness is a core driver of many pathologies. And it makes total sense that if you improve metabolic fitness, that you would reduce the severity and onset of disease. So I think that's fundamentally what an aging drug, in the case of Loyal, in the case of I think a lot of people in the field, some of the people in this audience are working on. Despite the fact this is all like super awesome, like obviously we want a pill to reduce the risk of disease, like obviously this makes sense. You actually, and this is where we're gonna start getting to potentially the spicy bit, and maybe you can be interactive because I know there's a few different longevity theses and companies represented in the audience today. We can't actually develop a drug for classical aging, lifespan extension today in humans. And the reasons for that are interesting. One kind of baseline hypothesis, which I'm happy to debate, is like actually the biology for first generation drug is already there. The challenges that you see are much more difficult. A quick interlude, which is I want to talk a little bit about what is an aging drug, because this is actually a really big debate in the field. So there are a lot of aging companies. There's a lot of people studying mechanisms of aging. We just had one go public, BioAge, Cambrian Bio, Gordian, lots of companies that are working on this. So why am I sitting here saying you can't develop an aging drug for humans today? And the fundamental reason is that all of these companies, from the fact that I'm aware, because of these restrictions that I'll go into in a second, that again are not biological, are much more socially driven, much more logistically driven, are not able to actually test a drug for this use case that we're talking about previously. They're not actually able to test a drug for reducing broad cause mortality, reducing morbidity, reducing risk of disease. As far as I'm aware, all of these companies are developing it for specific indications. Some like more representative, some less representative, but all not classically aging. And so my spicy take is that this is extremely valuable. I think there's a lot of interesting biology to be had and learned from aging to be applied to specific diseases. But we have a fundamental gap here, which is still not a classical longevity drug in the way that we have imagined it in the preclinical literature. In the way that we've had, 100+ compounds show lifespan and health span extension in mice, none of that has translated out into humans for that explicit use case, right? There's a lot of interesting work done on, I was talking with, I don't know where you are, somebody from Altos is here, hey, last night about how they want to do liver regeneration. Very, very cool application. It's if you can change that, like that was a huge way to open people's eyes, but it's still different from, a drug that somebody's prescribed to extend lifespan. Same with things like, Unity Biotechnologies did ocular disease. They did osteoarthritis of the knee. Restore Bio did immune deficiency with aging. And so I think this is actually one of the biggest challenges of the field right now is there isn't this cohesive path to do this in humans today. And so this was really what, when I decided I wanted to start Loyal a few years ago, this is really what the problem I wanted to work on is how do we create that path so every company that has an interesting way to attune aging in one way or another isn't all, in addition to taking on a shit ton of biological risk, isn't all taking on a shit ton of regulatory risk too. Like how can we nuance down the regulatory risk so we can test drugs for this? I think it's really important for the field and for public health. I think it's also really important just from a mechanistic standpoint, right? Because it doesn't necessarily track that a drug that could broadly extend quality of life and health span and therefore lifespan would also be sufficiently efficacious at a specific use case. So one like maybe slightly tired metaphor in the aging field that I really like is the car, right? So, cars have rubber in lots of places. You have rubber in your tires, you have rubber in your door seals, you have rubber in your engines if you still drive an ICE. And if you had some sort of magical way to like wave a wand, give your car a drug to extend the resilience of that rubber, to extend the resistance to UV, to heat, to friction, to all of these things, you would extend the quality of life of the car, right? You would extend the amount of time before you had to go and treat the specific things that go wrong with the car. But when that rubber does start aging, does start declining, the diseases that you see are very different, right? You might get some wind noise if the rubber starts cracking in your door seal. You might get a flat tire if your car tire rubber starts cracking. And at that point, the intervention is completely different, right? Like, fixing the door seal is not gonna do jack shit for your tire. And so again, like with a drug, like one of the things I fear in this field is because of the regulatory and structural and societal constraints on the field right now, people who want to do things that are broadly targeting just, rubber aging and rubber resiliency as a whole are instead being forced to target, tires or door seal integrity. And then their drugs might false fail, even if they would be properly efficacious for extending the health span of the car. So that is, I think, actually one of the biggest challenges of the field. And if we have a few too many false fails, it can be very difficult in terms of a funding and investment and just like people input in the field. Okay, interlude over. So why can't we actually develop a drug for aging today in humans? Couple quick reasons. One, extremely long feedback loop, decades to see lifespan extension. There's no regulatory path. Again, we've all talked about this. With most other drugs, if you're going and developing a drug for breast cancer, you know what the standard of care is, you know how you prove efficacy. It's very difficult, don't get me wrong, but at least that's one variable that's nullified. There's also a lot of incentive challenges, at least in the US. Preventative medicine classically struggles a bit more from a reimbursement standpoint. Again, statins and whatnot like show there's a pretty clear path, but it still isn't, it's still more difficult than something like, you're seeing these gene therapies that get funded for like these very acute, very terminal diseases. The incentives are a little bit more aligned there. And then finally, it's fucking expensive and it takes forever, right? The classic numbers are 9 years, 1 billion to market, 7% approval rate. These are all like average numbers, right? Like, but the point is that if you want to do it, it takes a lot of money. Whether you do it with $500 million or $1 billion or $2 billion or 7 years or 12 years, it's going to take you a long time and it's going to take you a lot of money to get there. And again, the things I want to point out here is that these predominant reasons are structural. These aren't biological. I'm not saying here, we don't know, like we don't have the science, right? To be clear, we don't have the science for immortal humans. But actually, to my opinion, the biggest reasons we don't have a longevity drug today are actually much more structural than they are biological. Okay, so this is young me working at the Longevity Fund. And I was facing this problem, and I'd initially wanted to tackle, okay, well, this is a huge issue. We have all this great science, we have all these great companies founding, and they're all having the exact same narrative, they're all having the exact same challenge, they're all developing their drugs clinically for these specific indications because there's no regulatory path. Like, I want to work on this. And I really saw it as two paths, right? Should I go and tackle the problem head on? AKA, should I try to create a regulatory path for lifespan extension in humans? This is dark, scary, lightning, craggly trees, because very difficult, right? Like, you really don't want to work on things where the headwinds are against you or the winds are against you. And for all the reasons I've said, candidly, just the money reasons alone, those headwinds are really, really facing against you. And so the light, beautiful, airy path that I decided to take instead was, could we find something clever? Could we find a hack? Could we find a way around that potentially also unlock this problem that I'm talking about here today, but perhaps didn't require me to go through, hell first to get there? And so that is where Loyal came out of. Loyal, I'm, to be clear, a huge animal person. I've been an animal person my entire life, but Loyal really was the realization that we need drugs that are FDA approved for lifespan extension, and that we could do it first if we went into dogs. So again, the really high level thesis of the company, I don't think is gonna be particularly shocking to anybody here, is this idea that dogs are a wonderful market for a multitude of reasons alone, but also if you develop drugs to extend dog lifespan through this FDA approval process, it also unlocks human aging, both directly and indirectly. So how does it do that? Well, for one, the structural alignment is much more in your favor, right? So while you have these really long feedback loops in humans, decades to see lifespan extension, we're currently running a pivotal lifespan extension, placebo-controlled, double-blinded, FDA-concurred, all the rigorous shit lifespan extension study to enable the full approval of our drug for lifespan extension, and that's going to take 5 years. That's a long time. It's not that bad, right? Like, you can survive as a company for 5 years. And really interestingly, it actually only takes about 6 months to see biological aging in a dog. So we can actually see biological objective changes in the dogs that we study in about that 6-month period. Therefore, we can see a deviation or improvement in those factors much faster. There also is an accelerated regulatory path available to the veterinary FDA. This was actually probably the biggest unlock for this company, something called expanded conditional approval. I'm happy to talk more about it. But it basically means that you need to have your full safety, full manufacturing, but only reasonable expectation of effectiveness to actually begin selling and marketing your drug for your claim. And then you run your pivotal study in parallel. And that was a very big unlock, because it made our go-to-market from 9 years if we had to do, or 8 years if we had to do a lifespan extension study first, to more like 4 or 5. Aligned market incentives. Every dog owner, dog pair, I like to call as like a little single payer healthcare system, right? I care about my dog's health today. I care about my dog's health in 5 years from now. I'm willing to pay money now to save myself time. or save myself money in the future. It is, again, there's no reimbursement, which can be very challenging. You do have to, optimize COGS. You have to create a product that's cash pay accessible. It makes any like spicy modalities really challenging. But I do think this aligned incentives, again, like where can you get the wins behind you, is extremely, extremely helpful in terms of people wanting preventative medicine, right? And also, I'm happy to talk about the market if it's interesting, but like at a high level, the most successful dog drugs are all these preventative drugs. And last but not least, it doesn't take that long. And it doesn't take that much money, relatively speaking, to get a dog drug approved. It's about 3 to 4, maybe 5 years to get a dog drug approved. 4 if you're running fast, 5 if you make a lot of mistakes on the way, like we did, and about 15 to 30 million, depending on how spicy your pivotal trial is going to be. And there's about a 90% approval rate. This is not because the FDA has a lower standard for veterinary medicine, which is a common misconception. It's because you test your drug in dogs and then you bring it clinically in dogs. So if you can model your indication in a laboratory dog, which we've figured out ways to more acute indications are even easier, you have pretty damn high certainty that drug's gonna work when you bring it into the clinic. It's really more confirmatory and showing if there's any, variation in breeds, for example, that you need to be careful of. And so this makes this, a much more fundable company, candidly. And it also just makes it, able to take on a little bit more risk because the numbers play out so nicely. And the reason why this makes sense is threefold. One, dogs age like us. They're one of the best models of human aging. Again, I'm happy to go more into the science if it's interesting. But at a high level, we have this really unique relationship with dogs. We've co-evolved with them. We share an environment with them for tens of thousands of years. They get the same age-related diseases we do at approximately the same time in their lifespan. Actually, the one big exception is cardiovascular disease. Dogs don't get cholesterol-mediated cardiovascular disease like humans, partially because they metabolize cholesterol differently, and partially because the environmental factors. Dogs can't go to McDonald's, so they get to avoid that a little bit. But cancer, dementia, osteoarthritis, sarcopenia, like inflammation, all of these diseases that we see in humans, dogs represent it pretty excellently, candidly. There isn't a huge variance in how it represents it. And they also are the largest medical market behind humans, which is important, A, for TAM, but B, because it means that we have EMR records for these dogs, right? So we actually have access to Banfield, which is one of the largest veterinary chains in the US. I believe over 20 million vet visits that give us diagnostic data, phenotypic data, and we're also looking, I was talking to somebody who had been a part of our saliva study, developing epigenetic markers of aging. All of these things you're able to study and do because there's such a wide swath of data available for dogs. Another fun thing, and kind of hot off the press, we're currently recruiting for this lifespan extension study in dogs, and we had a piece of press in like Fox News on Dallas or something. Everybody loves dogs. And we got over 1,000 dogs in 24 hours registered interest for the study. And about 800 of them are actually qualified potentially to participate in the study. And that's insane, right? That's like bigger than any animal health study. You can't really do that in human health. Like also just like nobody wants to cover your like human health clinical trial like in the news, right? People do it because it's cute, it makes them feel good, makes them happy. And that's a really like huge competitive advantage that you have in dogs. Structural and regulatory advantages, I talked about this already. And last but not least, one that I actually really didn't appreciate going in, but I now, as somebody who has to fundraise a lot, really appreciate. I can feel the founder pain in the room, is the fact that we can make revenue. Comparable dog drugs make over $1 billion a year, sometimes more as a class. HeartGuard, which is the leading heartworm preventative, of which there's like 50,000 generics right now, made about $500 million in sales last year. Even though, there's 10 copycats because people just trust HeartGuard so much. And so this is really exciting because it means then we can break the shackles, right? Like if we don't have to go have this conservative biotech investor base to go raise $2 billion to bring our drug to market, we can go and say like, F you, like we're gonna go spend $300 million on a pivotal human lifespan extension study, right? And that's just something that's really, really difficult to do if you're tethered to any sort of kind of traditional fundraising structure. Honestly, even just having the leverage to negotiate, even if you still need a raise, because you're profitable and near profitable, is just extremely valuable. So this is our thesis, right? It's helping dogs first to help humans. And then I want to share a little bit about what we've done. We got the first protocol concurrence for a lifespan extension study. Basically what that means is the FDA has committed, written in blood, that if we run this study in the way that we've designed it and concurred with them and, run the stats in the way, and then we show a statistically significant reduction in mortality risk in the dogs treated with our drug compared to the placebo, we will have a fully approved drug for lifespan extension. That's the primary claim. The secondary claim is quality of life improvement, which I hope we get a readout, but we put it as secondary because the measures are a little shit for quality of life, and you don't want to rely on that. But this was very important, right? This is the first time, as far as I'm aware. So that was fun, lots of design. It took us a long time to design this study and get that right. And I think probably the milestone we're most proud of is we got the efficacy approval for our big dog short lifespan drug, which was the first time this has ever happened for a longevity drug. I mean, it's a massive accomplishment for any indication for any drug, but was, it was really like a no backing down moment, right? At any other point, even when they said yes to the claim and yes to all the other things, they couldn't. They could have still made our lives very hard or made the standard, almost impossible to meet. And this was really like, no, like the path is here. And also we think you've met the path that you set. So we're working on this for other drugs now too. But the thing I've told my team and I feel really strongly is I really hope that this regulation is law. And I really hope this precedent and other precedents we hopefully set helps everybody in this room and everyone else develop drugs for lifespan extension, because we are bound to the same federal regs under veterinary FDA as human FDA is. So theoretically, this precedent should transfer over, theoretically. Logistically, a little bit different. Okay, the last little bit I was gonna go into is just some hypotheses / frameworks we've had for why we've made regulatory progress. I thought this would be interesting to talk about because I know a lot of people here are like me, where maybe you're not independently a billionaire and you're like, oh man, how do I make change in the world without $1 billion to go lobby the White House? And same. And this was something I thought about a lot at Loyal, especially as a tiny company, trying to figure out, how could we enact this regulatory change that people have been bitching and moaning about literally longer than I've been alive, to try to actually, make some steps forward here. So these have been our philosophies. Again, the first thing that we held super non-negotiable, in the culture of the company, in everything, in every conversation I had with investors, is that we are gonna be, I hope, the first drug to be approved for lifespan and health span extension. We don't negotiate with terrorists, right? We're not doing an indication. If we got forced to do an indication, Loyal was dead, right? And that was, I think, being all in or out was very, very, very important, both culturally, and it forced the team to figure out a way to make it happen. And I'm sure it bled into some of the work we did with the agency also. So that was first and foremost. So we were really contrarian, really radical, really bought into one very specific idea, but radically boring on everything else. So this is really the one area where I'm fuck yeah, dog longevity drugs, let's go. Everything else, I'm the most buttoned up pharma person ever, as is my team. And I think that's actually really important. I think you don't want to innovate on 5 variables at once. Innovate on one variable that you really care about the most and hold that constant. And then everything else, make it easy for them to support you. And I think this is something that a lot of SF tech in general gets wrong, because there is a lot of innovation to be had. There is a lot of suboptimalities, but it does have to be a stepwise process when you're dealing with regulatory bodies. One of the things we also did well was framing the thesis in well-accepted frameworks. We didn't really go and be aging is a disease. Again, another thing that the field screams about, FDA is not gonna accept that. Who cares? It doesn't matter. It's not rate limiting, right? We instead frame rated our thesis and what we want to do, lifespan extension, around things that the FDA already understood. So preventative medicine. I talk about longevity, lifespan extension in groups like this. In FDA, it's all preventative medicine. Drugs to reduce the risk of mortality and morbidity due to age-related diseases. Drugs to target the primary, well-validated drivers of pathological aging in dogs, right? Really, really tying it. We did studies that tied these things to quality of life markers in dogs. Oh, see, look, when you have a dog that has accelerated metabolic decline for its age and weight, it has a worse quality of life as measured by its dog owner. We actually showed that statistically, which was really cool. That was really important. The statins metaphor is something I've used a lot. And I think maybe the most interesting and clever thing we did, or at least currently clever, and I hope I don't jinx it, was for this drug that got the efficacy approval, we linked it to genetically associated diseases. So most dogs are very inbred, breeds are not natural, and dogs get, the bigger a dog is, the shorter their lifespan is, right? You know, if you have a Great Dane or the Newfie, a Newfie or a Great Dane might live 7 or 8 years, while a Chihuahua lives 18 years. Everyone's like, oh, that's just normal, right? Like big dogs just have short lives. It's actually really fucking weird, right? Like you don't see 2x differentials in lifespan within the same species. And usually bigger mammals live longer, not the other way around. Long story short, it looks like we gave big dogs a genetically associated disease for accelerated aging, basically the pathways that we inadvertently selected for to make a puppy grow big in puberty, also regulate rate of aging, so these big dogs are literally aging at a 2x faster rate. That's all important here because it meant that we were able to associate the longevity mechanisms that we were targeting these big dogs to something the FDA already understood, which is that dogs have genetic diseases due to historical inbreeding. And so it gave them like a link, right? It's like, it's a disease, but the disease is accelerated aging, right? And that was like that first introduction to the framework. We're now doing things that are more like holistic aging. Actually, our first drug, fingers crossed, is just for generalized senior dog aging, but really kind of introducing the thesis in this way in like a very romantic biology. I mean, I'll never know for sure, but I think really, really helped bring them along. Again, because it was one less leap. Yes, it was aging. Yes, it was lifespan extension, but it was in these dogs that are aging really, really fast. And there's a lot of comps that you can look at too, on even the human side. We collaborate a lot with non-aging scientists. In fact, we've hired some people with an aging background at Loyal, but we majority hire metabolic scientists, neuroscientists. We collaborate with those externally. And I think this has been very helpful, again, from a how do you bring in the frameworks that have already been well established into a field that sounds fringe or new. This has been very valuable for us, both from a scientific culture building perspective, and also, again, from a regulatory perspective, veterinary scientists being another one, obviously. And this is crucial also. Safety first. And I mean safety in a multitude of different ways. Well-validated safety of the mechanism of action. Not getting cute on MOA, not getting cute on, the safety of the modality. Trying to pick drugs that had a well-understood on-target and off-target binding, and mechanisms that had well-understood adverse events. This was really crucial because we really wanted to tell a story that it might not work, but it won't do harm. The drugs that we've picked have margins that are an order of magnitude or so, in one case, 2 orders of magnitude higher than what's required by the agency. Is that gonna be the case forever? No. Right? We're going to develop drugs that have more of a risk-reward profile. In fact, we're just locking in what our hopeful 4th drug will be, and it is going to have more of a risk-reward profile. But we feel comfortable with that now because we've set the precedent on a drug that was just so unbelievably safe that you literally could give a dog 100x the dose, and they would have a little bit of diarrhea, which is unpleasant, but not deadly. And so that's been very, very important for making this regulatory process. And the last thing I'll say on this is, I think I have a point in here too, is really empathizing with the agency and understanding their concerns. If they go out on a limb and they approve some crazy drug for longevity from a CEO, and it's this random woman who didn't even complete her graduate school and isn't a vet and is Silicon Valley, that's how you get fired, right? If there's some big safety crisis, I really wanted to make them feel like they could trust us. I hope they do trust us. And I wanted them to make them feel that there was we have really been thoughtful to mitigate the downside risk of doing something like this and kind of coming along this journey. 99th percentile regulatory filings, you would not believe how common it is for people to write shit regulatory filings that try to get around, try to hide data, are just unclear and ununderstandable. We spend a lot of time making sure these are well-written documents. We consult with people who have been doing this for decades, who have led the approvals of some very important drugs, and we tell them, red line it up, destroy this document. We go through multiple cycles for each one. Again, you would not believe how common it is for people to send pretty shit filings in. And by the way, shit doesn't mean it's badly written. It just might be badly written for what they need. But regardless, it's bad. In that same vein, empathizing, again, just understanding. I think there's this history / bad pattern in the aging field to demonize the FDA and be oh, we'd have all these aging drugs if only the FDA would like let us like declare aging as a disease, and like, gosh, they're so conservative. Like, we should just go to like some random island that we've incorporated where there's no laws. And don't do that. Like, it just makes the field look fringe. Like, I think the best thing we can do is make this like so fucking boring, right? Where like, oh yeah, like there's like a drug being developed for this. There's a drug being developed for cardiac, and it's just a preventative drug that has multiple mechanisms instead of one, or multiple positive effects instead of one. I think that's the biggest unlock, not trying to like pretend like we're so different in some different fringe aspect of biology and drug development that like doesn't need the FDA. And by the way, like FDA is good on both sides. Like, I don't want to be responsible for bringing a drug to market that kills dogs, point blank. And it gives me a lot of like confidence knowing that I will only ever be able to prescribe a drug, or our veterinarians will only be able to prescribe a drug if an independent body that has zero incentive for Loyal to succeed besides caring about science believes a drug is safe and effective. I think that's actually like a very powerful confidence builder. The last thing is just bringing non-aging experts to our side. So again, just not being in the aging bubble. I wanted to end it with some cute photos because I've been yapping at you guys long enough. Here's a Great Dane who will hopefully live a longer and healthy life. This is actually at one of our studies where we were trying to understand and quantify how does a dog age from like a metabolic and biomarker standpoint versus a dog owners and veterinarians' independent assessment of their quality of life. Showed a lot of really cool things there. This is the epigenetic study we did. Over 1,000 dogs signed up in less than 24 hours to send us their DNA/spit. Found a lot of cool stuff from that. And then this is one of our conferences. We also do a lot of work on trying to make like a beautiful UX and a consumer-friendly pharma brand, which I could talk about SciComm all day, but also helpful, I think, to have this kind of like warm friendliness. Okay, that's all I got. Thank you, guys.